Hello everyone. This is a problem from the chapter current electricity. There are some resistances and some capacitors connected across a battery of EMF B. So let's read through the problem once. In the shown circuit, all three capacitors are identical and have capacitance C microfarad each. Each resistor has a resistance of R ohms. An ideal cell of EMF V volts is connected as shown. If magnitude of potential difference across capacitor C3, this capacitor, in steady state is A upon B volt, then we have to find the value of A into B. So basically we have to find A and B here, and this A and B will be A by B will be a proper fraction, and then we will calculate A cross B. So let's solve this circuit. I have the diagram already. Let's enlarge it a bit. In steady state, there will be no current across the resistances. So let us say if 2I current comes out of the positive terminal of the battery, I will go across this lower branch, and another I will go across the upper branch. So we can easily calculate I. All these three, either you can solve apply Kirchhoff's law in the upper loop, the largest loop, or in the lower loop also you can apply and solve. So if I apply Kirchhoff's law in this loop, I can directly get I equal to V by 3R. So from here I can write the value of IR, which will be the potential drop across any of the resistors. This will be V by 3. So if I take the potential near the negative terminal of the battery as 0 volts, and if I move across the battery like this, we will get a gain of V volts. So this point will be at V volts. Also this will be at V volts, and this will be at V volts. This all these two will be at 0 volts also. 0 volt. And since IR is V by 3, there will be a potential drop of V by 3 across this resistance. So on its left the potential is V, and if there is a drop of V by 3, the potential at this point will be 2V by 3. This potential will be 2V by 3. Similarly, there will be another potential drop IR across the middle resistance, and IR is equal to V by 3. So another drop of V by 3 will imply the potential at this point will be V by 3. Similarly, for the upper branch also we can write the potential at different points. This will be 2V by 3, and potential at this point will be V by 3. So we have more or less written the potential of all the points except one point. This point the potential is not known. So let us assume the potential is X and apply nodal analysis. Since this part of the capacitor plates is isolated, the total charge will be 0 there. So if I apply nodal analysis at the point X and write the charges, the charge on C1, the lower plate of C1 will be X minus 2B by 3. This is the potential difference, and into C. Similarly, the charge on the upper plate of C2 will be X minus 2B by 3 and into C, and charge on the left plate of C3 will be X minus V by 3 into C. And all the sum of all these three charges must be equal to 0. Since this is an isolated node, it is not directly connected with the battery. So we can easily cancel C, and there will be 3x, and 2b by 3, 2b by 3 and b by 3 will make 5b by 3. So 5b by 3 on the right hand side, and from here we get the value of x, that is the potential of the node. This will be 5 upon 9 volts. So the potential difference across C3 will be x minus v by 3. So potential difference across the third capacitor will be nothing but x minus v by 3, and x we have calculated. So this will be 5 by 9 v and minus v by 3. So v by 3 we can write as 3 by 9. So 5 by 9 minus 3 by 9 will give us 2 by 9v. And so this is the result for the potential difference across the capacitor C3, 2 by 9v. And if I compare it with what is given in the problem, it is A upon B times V. That means A must be, if I compare it with A by B times V, I get A as 2 and B as 9. So this implies A into B will be 18. So this will be the answer. I hope you get it. So in steady state, no current will be through the capacitors. So we have nothing but we have only choice to apply nodal analysis and get the potential x. Once we get the potential at the point x, we can easily calculate the potential difference across C3, and then we can solve and compare. That is all. This is a direct and simple problem. Thank you.